Okay, so we're going to talk about integration involving trig functions for exercise 708. So I have put three formulas here that come directly off the reference sheet, and I've also put us two standard triangles. I've done them in radians. On the reference sheet it's only in degrees, of course, but if you're doing calculus you must be doing radians. That's really important. Calculus does not actually work if you are not in radians. So our very first example here is a question where I've actually not given it in radians, I've given it in degrees. So what you need to do is actually convert this to radians, and you do that by multiplying it by pi on 180. So that goes times pi on 180. This is a linear thing. We don't need to use the chain rule in this form when it's linear, because you can just divide by whatever the coefficient of the x is. So it's now in radians because we've multiplied by pi on 180. Sine goes to negative cos. So it's negative, I'm leaving a space here on purpose, cos of that thing. I'm going to write the pi before the x actually, so pi x on 180. I need to divide by the pi on 180, which of course is the same as multiplying by 180 over pi. Plus c. Okay, so that's not too bad. Now this one is evaluate the integral from 0 to pi on 12 of sec squared 3x dx. Again, it's linear, so we can quite simply just divide by the 3. If this was not linear, then we would need something out here to match up with this rule. Okay, so the integral of sec squared is tan 3x. It's linear, so we just divide by the 3, and our endpoints are pi on 12 to 0, and then we just substitute in. So tan of 3 pi on 12, I might just put the third out the front actually from the 3, minus tan 0. Tan 0 is 0, so 1/3. 3 on 12 is the same as 1 on 4, so pi on 4. Up here, 1. So times 1, so equals 1/3. I may actually just throw in a quick chain rule question. So let's go the integral of, I'll just keep it simple, x cos 3x squared. Okay, with respect to x. So first of all, we look at what the derivative is of the inside. So d dx of 3x squared equals 6x. So we need a 6 out the front. We need that to be 6x. So if we times it by 6 on 6, I might actually just write that there this time. That whole thing is now following the chain rule. We have the derivative of the inside behind there. So our cos goes to positive sign. We've still got this 6 in the denominator, so we need that. That 6x is the derivative of this, so it'll get sucked up into it. 3x squared plus c.